All right, for this problem, this one came from another student, and this is a good question right here, because I don't have any of the and statements for something like this, but the question is good, so I think it's a good one for making a video here. And to start us off, we're going to write the solution in interval notation for this inequality right here, and it's an and statement, and that's okay, but the and statement is going to mean that we need we can only put into the interval for the solution where the two lines intersect or overlap, specifically on the graph. So if we can understand this, I think this will make a little bit more sense. Now on my number line, I always like to see where 0 is, so I'm going to put 0 there, and then the proportionality of things doesn't really matter after that, so we got 7 and 17, something like this, right? So we're going to show this, and I'm going to start by putting x is greater than 17 in red. Now it's just greater than 17, so I'm going to put an open circle here at 17. And since it's eating the x, I would move to the right on the number line. Everything to the right of 17, 18, 19, 20, and so forth. All of those values, all the way up to 100 billion and to infinity, will make this inequality a true statement. Now we need the and to be true, so it needs to be true not just for this one, but it also needs to be true for this one as well. This one and this one together. So we're going to do this one in, we'll do it in green. So x is greater than 7, I'm going to do in green. Now it's just greater than 7, it's not equal, so that's going to give us an open circle there. But again, it is eating the x, which means my number or my line is going to go to the right. Okay, so something like this. Now there's a couple problems that we have because we're looking at an and statement. It has to be true for this one and this one. This line right here, up to the point where I get to 17. Okay, so at this point right here at 17, we'll pretend like I drew that much better than I did. But at that line 17, anything to the left is false for the total compound inequality there. Why is that? Well, it makes this one true, but it doesn't make this one true. It has to be one and the other, one and the other. So this area right here for the green is not actually making this one true. It has to be true for both. So where does it start? Well, it doesn't actually start at 17 right there. What does that mean? Well, it's true for the green at 17, but you see how it's an open circle at the red? So that means it's false for one at 17, but it's true for the other. It has to be true for both, one and the other. So starting at 17, right here, we wouldn't include this in the interval. So we're going to make it not included with an open parentheses there. And then this goes all the way to infinity for both green and red. And then, of course, we would close that with a parentheses and not a bracket because infinity is never included because it's a value that we can't define. So this right here is the interval that we're looking for. And again, if you're wondering, well, yeah, that doesn't make sense to me why the 7 is not included. If this was an or statement, we would include the 7 because it only has to be one or the other. But remember, and indicates we're looking for where the two lines intersect or overlap on the graph. That starts here at 17, kind of, except 17 is not included. But that's where it starts. Everything to the right is included. So again, you could say values of 19, 20, 50, 125, all the way to the right to infinity would make both of these true, but they don't start making both true until you get to 17. So hopefully that helps. But that's all we got for this one. And, well, we'll see you guys in the next one.